Hello, grade 8 math. This is lesson 4.7, surface area of a right cylinder. We need to review some terms from last year, and because we're going to use them for this unit. If you struggle with this, please find my grade 7 math videos. If you click on my name just below this video, you'll be able to find them, and find the ones that have to do with area of a circle. So before we start, we need to define some terms. So first one here, this green line that goes around the circle is a measurement called the circumference. Circumference, which is lowercase c. There's a line that goes straight from one side of the circle to the other. The furthest measurement, this is known as the diameter, and it always passes through center and splits the circle into two halves. So it can't just be some random segment that's going some other way. The radius here goes from the edge to the center of the circle, and that's used r. Diameter was d, radius is r. And then there's this blue shaded in area, two-dimensional space would be the area of the circle. Now there's some boxes that go around some things here. I would write them down, the ones that have the boxes around them, because they are going to be quite useful. Now, there's this number that's known as pi, which is approximately equal to 3.14. It's a cool symbol. There are more digits, I should mention. That's why there's this dot, 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 the ellipses here, because there's lots of digits, and there's mathematicians trying to figure out if that number ever actually ends, and I don't think they've found that to this day that I'm making the video. So pi is this relationship between the measurements, these straight line segments, compared to the circumference. And so they use this quite a bit, and we'll look at what it means a little bit later here. But first, let's talk about area. How do you calculate the area inside a circle? Well, you take this number pi, 3.14, or if you're using your calculator, just press the pi button. That's what the answer key will have, is using the pi button. You'll be a little bit off if you use just 3.14, but there's some grace there when I'm marking it. The area is equal to pi r squared. So pi times r, and square means just square is r, so you times r again. So pi times r, and that will give you the area inside. And remember, because r and r will be straight unit, when you multiply them by each other, you're going to have a squared unit. So if it's centimeters, you'll have centimeters squared, which area always is a square unit. Next is diameter. Diameter is letter D. It is equal to 2 times r. Think about it here. The diameter is 1, 2 of these radius, right? Radius could be drawn anywhere here from the side to the center. It'll be the same measurement. So you have 1, 2 that are the same. So radius is 2 times, diameter is 2 of these radii. So 2r. Next one here is just kind of the opposite. Well, the radius is just simply this diameter measurement divided into two segments. So the radius will be diameter divided by 2. Diameter divided by 2. Finally, circumference. This is where pi comes in. The circumference, there's two formulas for it that use these two over here. The circumference is pi times d. So some mathematicians, they figured out that if you take the diameter and you multiply it by 3.14, that will give you this circumference around the circle. So the circumference is 3.14 and a bunch of digits times as big as the diameter. So if you know the diameter, you can calculate circumference just by multiplying the diameter by pi. But we also know that make sure you write down these things here so that you can reference them later. Alright, now we're going to take some time and we're going to think about cylinders. How could we apply what we were talking about with the surface area of rectangular prisms and triangular prisms? and now apply it to cylinders. Now a cylinder is a shape, a polyhedron I should say, much like this one that a student 3D printed for me with my name on it, which is kind of cool. It has a circle on the one side, a circle on the other side that's congruent, the same size, and then it has something that connects it. If we were to take this cylinder and crack it open and flatten it out into a net, what would it look like? Well, it would look like this. We take our cylinder and we crack it open, it's going to look something like this. Now, these circles could be anywhere along this line or this line. They could move around, and it would be the net of a cylinder. Now, it's kind of neat. So if you look at this, watch as I wrap this rectangle. Okay, so it's a rectangle that connects the two circles. What happens if I roll this rectangle around? Notice that the circumference of this circle that's drawn with purple there is equal to this length of this rectangle. Let me do that again. Notice that this rectangle, that edge that it's going to form is right where the circle lies, and it's the circumference of the circle. So they are equal. So if you know what the diameter is or the radius is, you can calculate the circumference using these formulas from before. 2 pi r if you know the radius, or pi d if you know the diameter. Right? And if you know that circumference, then you can know the edge of this rectangle. And why is this important? It's because when you're calculating the surface area of a polyhedron like a cylinder, to do so, you need to calculate the area of all the shapes, the two-dimensional shapes that make up its net. So if we get the net, we make the net, what would we need to calculate? There'd be 2 circles that we need to calculate. Okay? And we'd multiply it by the area of those circles. So 2 times the area of the circles is part of the surface area that we'll be looking for. And the other thing that we're going to be needing to get the area of is the area of this rectangle. And that area in this case, when this is 5 meters across these circles, this length that connects one circle to the other, so if this was your cylinder, this would be 12 from one circle to the other. That's what this measurement is saying, 12. And this edge, or radius, would be half of 5, which is 2.5, or we can use diameter, which is all the way across, which is 5. That's what it said here. So the diameter is 5, the length is 12. So to get the surface area of this, the surface area of the rectangle, which is 12 times circumference, plus 2 times the areas of the circle. So what can we do? Let's calculate the circumference, let's calculate the area, and throw whatever those numbers are in here, which I've already done it on the side. To calculate the circumference, it's going to be pi times d, and we know that d is 5 meters in this example. So 3.14 times 5 is 15.7079 meters. So that circumference measurement, I'm going to throw into this formula here and put it here. 12 times 15 will give 188. And then we need to do the area. Area with our formulas that we wrote, those ones at the top of the page and those brown boxes that we wrote down. Area is pi times r times r. But we don't know r. We could calculate it. So one way we could do it is take r is diameter divided by 2 and figure out that that means r is 2.5. Or we can do it this way where I've kind of did the whole thing together. We don't know what r is, but r is d over 2. So 5 over 2, which is 2.5, and we're going to square that 2.5. That's what this 2 means. We're going to take this and do it. So if we know radius is 2.5, radius times 3.14 is 17.63495. This step here is often the one that people mix up because for some reason they multiply these two and then they multiply by 2. Squared does not equal times 2. It does not equal times 2. Squared means you take whatever is the number right before these brackets, whatever's in this brackets, or whatever this value is, and you multiply it by itself, which I've done right here. Okay? And so then, now that we have the area, we can throw it into this formula. Area is 19.6349 meters squared. Which 2 times that, because we have 2 circles, we need to multiply it by 2, is 39.2698, and then we're going to add all these up, and we're going to get 227.7646, and that's approximately equal, I made a little mistake there, approximately equal to 228 meters squared. And if you're in that ballpark, because some of you might use 3.14 for your calculations, and some might use a pi number, our answers for our assignments will be a little bit off. So as long as you're rounding to that same precision as these numbers were at the top, we'll go with that. So these had a whole number in, there weren't decimals in these numbers. If there's decimals, keep as many decimals as the one that has the most for these math questions. In physics in high school, you'll find out that you're supposed to follow some significant figures rules. We won't deal with that yet.